1 minute ago, heat from Campi Flegrei surged so intensely that it began warping walls and floors in the towns above, an unstoppable force turning everyday homes into volcanic outposts. Over 500,000 people live on top of this hidden caldera west of Naples, and experts now admit the danger is far greater than believed. If the official risk assessments were wrong, what is really happening beneath these streets, and why can nobody stop it? Campi Flegrei stretches across 13 kilometers of land that looks nothing like a volcano. No towering cone pierces the sky, no smoking peak warns of danger below. Instead, the caldera sprawls beneath neighborhoods, football fields, ancient ruins, and busy harbors. Its rim barely noticeable except to geologists who know where to look. More than 500,000 people live directly above this volcanic system, crowded into what authorities now call the red zone. Beyond that, over 3 million residents of Greater Naples work, shop, and raise families within reach of its power. The caldera formed 39,000 years ago when an eruption so massive it emptied underground magma chambers left the ground above unsupported. The Earth collapsed inward, creating a crater wider than Manhattan, with its southern edge now submerged beneath the Bay of Pozzuoli. Over millennia, the landscape filled in with towns and farmland, roads and rail lines. The original scar almost disappeared beneath the marks of civilization. But the volcano never stopped breathing. The volcano's power is written in its past. 39,000 years ago, a blast unlike anything in recorded history tore open the land west of Naples. The eruption emptied so much magma from beneath the surface that the earth above caved in, swallowing forests, rivers, and ancient settlements. What remained was not a towering peak, but a sunken expanse 13 kilometers wide, rimmed by low hills and in places edged by the sea. Scientists rank that eruption as VEI 7, one of the largest in European history. Ash from the blast blanketed the Mediterranean, and the ground itself collapsed by hundreds of meters, creating a crater that would shape the future of the entire region. But the story did not end with that collapse. Over the millennia, at least 70 more eruptions pierced the caldera floor, each one leaving behind new craters, domes, and steaming fields. The most recent eruption in 1538 built the hill called Monte Nuovo in just a few days, an entire landscape feature rising from farmland within sight of terrified villagers. Historical accounts from that period describe darkness at noon, choking ash, and ground shaking so violently that homes split open. For weeks, the air was thick with sulfur and crops failed across southern Italy. Even centuries after the last eruption, the land has not settled. The caldera floor rises and falls in slow, powerful pulses, a phenomenon called bradyseism, sometimes lifting the ground by meters in just a few months before sinking back again. In the 1980s, tens of thousands of residents were relocated from Rione Terra, the historic district of Pozzuoli, in forced evacuations when authorities believed the sharp upswell could signal an imminent eruption. Police and military forced people from their homes, and this oldest quarter was seized permanently by the state. Today, tourists wander still empty streets while the volcano continues its restless cycle beneath their feet. But this was only the first warning. At the heart of Campi Flegrei, the Solfatara Pisciarelli vent system has become the epicenter of a new and unmistakable threat. Automated sensors at Pisciarelli now register vent temperatures as high as 165 degrees Celsius, according to INGV monitoring data from 2025, the highest ever recorded in modern observation. Just a decade ago, readings hovered closer to 110 degrees Celsius. The change is not just in heat, but in the violence of its arrival. Carbon dioxide emissions from this single vent system have surged from approximately 1,500 tons per day before 2017 to between 4,000 and 5,000 daily by 2024, ranking Campi Flegrei among the top volcanic CO2 emitters on Earth. These are not abstract figures. Each spike in temperature and gas output is matched with tangible consequences: scorched earth, shriveled vegetation, and a pungent sulfur odor that clings to the air for blocks. Ground teams from INGV have logged field temperatures near vent proximal walls at over 50 degrees Celsius, and in some abandoned buildings just meters from the Pisciarelli vent, the heat inside is so intense that floors have warped and mineral crusts have formed thick layers along baseboards. The pace of change is relentless. In 2023, a swarm of shallow earthquakes rattled the district, and monitoring data showed corresponding spikes in gas emissions at Pisciarelli. Through 2024 and 2025, as vent output intensified, civil protection responses have evolved to match the growing threat, with access restrictions implemented in the most affected areas. The numbers on the monitors are warning signals, but the evidence is everywhere for those who live nearby. Inside a deserted apartment block near the Pisciarelli fumarola, walls and floors have transformed into something alien. Every surface is coated in thick, crusty layers of yellow and white minerals, sulfur, silica, and iron compounds fused by volcanic heat. The original paint and concrete are barely visible beneath the deposits. In some rooms, the mineral buildup is so dense it blurs the corners between wall and floor, forming a hardened shell that cracks underfoot. The air hangs heavy with the sharp tang of sulfur and acid, a constant reminder that this is no ordinary decay. Civil protection records indicate buildings in this area were inhabited until the late 2010s. Based on patterns observed across the zone, complaints typically began with strange warmth in floors, then the appearance of mineral streaks along baseboards. Thermal imaging in similar structures has recorded floor temperatures approaching 50 degrees Celsius, while residents in affected buildings reported symptoms consistent with elevated carbon dioxide exposure. Civil protection teams have measured carbon dioxide levels in ground floor rooms exceeding 9,000 parts per million in some evacuated structures, far above safe limits.
Soon after, the building was declared uninhabitable. Doors and windows were sealed, but the volcano continued its work. Fumarolic gas found new pathways, punching through cracks and utility conduits, leaving behind a new crust with every pulse of steam. And the signs were already spreading. For families still living near the vents, the threat is no longer theoretical. In residential areas close to Pisciarelli, households face a reality that statistics cannot capture. At night, residents open windows to let acidic air escape, then check walls for blistered paint or fresh mineral streaks. In the most affected homes, children sleep with fans pointed at their beds. Because outer walls radiate so much heat, the plaster feels like a stovetop. If you put your hand on the wall, it isn't warm, it's terribly hot, one resident said in interviews with local media. Each morning, families inspect living rooms for new signs of damage. Some days, the mineral ooze has crept another inch up from the floorboards, leaving a yellow crust that flakes onto the tiles. The air smells sharp and metallic, especially after rain when gases push harder through the cracks. Financial strain compounds the physical discomfort. Repairs have swallowed thousands of euros spent on heat-resistant paint, makeshift ventilation, and repeated sealing of fissures that always reopen. Insurance companies refuse to cover the damage, citing volcanic exclusion clauses, and selling is not an option as property values have plummeted. But the ground had one more secret. GPS stations across the caldera show the ground has risen approximately 148 centimeters at Rione Chiara in Pozzuoli since 2005, with about 29.5 centimeters of that uplift occurring just since January 2024, according to INGV data. Ancient Roman structures once submerged have re-emerged from the sea at the old port, where boats now stand nestled in long grass on new land. The columns of Pozzuoli's temple of Serapis have fossils of mollusks halfway up, evidence they were once underwater. Each uplift pulse triggers swarms of micro-earthquakes. In May 2024, a magnitude 4.4 earthquake struck, the largest instrumentally recorded at that time, producing substantial damage and forcing the evacuation of tens of buildings west of the epicenter. Then, in June 2025, a magnitude 4.6 earthquake occurred, cracking walls and sending families fleeing from their homes. Scientists at INGV logged over 2,500 earthquakes in a single month during peak activity. The seismicity is concentrated in a highly populated area between Bagnoli, Agnano, Montenovo, and the Gulf of Pozzuoli, with most events occurring at depths between 2 and 4 kilometers. Evidence points to pressure accumulating in a shallow hydrothermal system beneath populated areas.
Research published in Nature Communications in 2024, using geodetic monitoring and petrological simulations, traced what researchers interpret as magma movement from approximately 8 kilometers of depth to around 4 kilometers since 2015, suggesting the source of unrest may be shallower than earlier models proposed. What came next defied all predictions. Scientists deploy networks of seismometers, GPS stations, tilt meters, gas probes, and thermal cameras across the caldera. The instruments track rising ground, clustering earthquakes, and hotter vents. Machine learning techniques applied to thousands of microquakes have identified ring-shaped zones of weakness encircling the caldera, structures that could focus future seismic activity. Yet the monitoring system itself has developed dangerous blind spots. In early 2024, several stations around the Solfatara crater went offline for weeks at a time due to geothermal damage and budget shortfalls. Critical data gaps emerged during periods of rapid change. Scientists cannot predict exactly where or when the next failure might occur. The range of possibilities includes more building failures, local hydrothermal explosions, stronger earthquakes, new vents opening unexpectedly, or a potential eruption, though no imminent eruption is currently indicated by the data. Based on monitoring of geophysical and geochemical parameters, researchers note that while the system shows signs of deep magma as the root cause of Brody-schism, there is no evidence yet of magma rising to very shallow depths that would indicate an impending eruption. The main risk in 2024 and 2025 remains seismic hazard rather than volcanic eruption. But nobody could have prepared for what happened underground.
Civil protection officials now face a crisis that outpaces their ability to respond. During earthquake swarms in 2024, tremors rattled Pozzuoli, cracking roads and triggering emergency responses. Shops and schools shut down. Emergency crews cordoned off areas where gas vents appeared, and temporary measures were implemented. Yet the challenge of keeping pace with volcanic unrest remains immense. Workers repair damaged infrastructure only to find new vents appearing in nearby locations within days. Across the caldera, this cycle repeats, where emergency fixes provide temporary relief before the ground shifts again. City budgets are drained, repairs are temporary, and officials quietly admit they can manage the crisis but cannot stop it. The Italian government issued Decree Law No. 140 on October 12, 2023, providing urgent measures to prevent seismic risk related to Brody-schism in the Flegreian Fields area. Hazard maps define red and yellow zones, evacuation drills run in schools and hospitals, and gas detectors have been installed in some homes. But bureaucratic delays, financial constraints, and the sheer scale of the problem slow response efforts. The building stock in the area, like most of Italy, was designed with obsolete seismic codes or without seismic provisions and cannot withstand ground motions from the most recent building standards. The volcano's acceleration is now measured not just in data, but in broken streets and sleepless nights. Among scientists, debate intensifies over what these signs really mean. Some researchers interpret the evidence as a system critically pressurized, with fractures weakening and building failures serving as early warnings of a major hydrothermal event or possible eruption. Others argue that Campi Flegrei has experienced unrest cycles before without erupting and may release pressure through small, chaotic events rather than a violent eruption. Research teams led by scientists included Giovanni Chiodini and Christopher Kilburn have challenged earlier assumptions about the depth of the magma reservoir. Using seismic tomography and gas monitoring, their analysis suggests shallow gas-rich zones may exist only 2 to 4 kilometers beneath the surface, closer than previous models indicated. Laboratory experiments using pressure analogs have explored how catastrophic failure might occur even without large-scale magma ascent to very shallow depths. Both camps agree on certain fundamentals. The system is hotter and more pressurized than it was decades ago. Exactly what will happen next remains unknown. And that terrified everyone watching. Communication between scientists, authorities, and the public has become a source of tension. Scientists speak in probabilities, while residents want clear answers about whether to stay or go. Politicians must balance risk warnings with economics and public calm.
Social media spreads both real footage of steaming vents and unfounded rumors. Residents are torn between trust in official monitoring, fear of the next earthquake, and a deep-rooted cultural connection to the land. The population density of approximately 85,000 inhabitants and 15,000 buildings in the deforming area, bordering Naples, Italy's third-largest city, makes evacuation planning extraordinarily complex. For many, the volcano is simply part of life, a force they have learned to live with even as it grows more restless. The reality is stark. A city lives in uneasy truce with the ground beneath it, adapting around warm floors and steaming vents, while anxiety grows. The volcano is already disrupting lives without erupting, forcing families from homes, closing roads, and consuming public resources. Daily routines continue, but the threat is no longer invisible. Heat presses up through foundations, gas seeps into basements, and the earth trembles with increasing frequency. Scientists track every tremor and gas release, knowing that the caldera's footprint covers not just Pozzuoli, but stretches into the heart of Naples itself. Emergency planners have mapped evacuation routes and run drills, but the sheer number of people, the tangle of roads, and the unpredictability of the volcano make rapid escape almost impossible.
What happens next depends on forces no one fully controls. The slow unfolding crisis could mean more evacuations, more buildings lost, more infrastructure failures. Or a sudden threshold event could occur. Stronger earthquakes, hydrothermal explosions, a new vent opening in an unexpected place, or a possible eruption on a timeline measured in weeks rather than decades. Ancient does not mean dormant. The forces that shaped this crater 39,000 years ago still move beneath the surface. Campi Flegrei is active, shallow, unpredictable, and writing its warnings into the city itself. Scientists know the caldera has risen 148 centimeters since 2005 and continues uplifting at rates of approximately 15 millimeters per month as of mid-2025. They know vent temperatures at Solfatara's main fumarole have reached 165 degrees Celsius, and CO2 emissions exceed 4,000 tons per day. They know shallow earthquakes cluster between 2 and 4 kilometers depth, and that magma appears closer to the surface than once believed. What remains unknown is the full timeline and ultimate scale of this unrest, whether the system will continue its slow pressurization, release energy through localized events, or cross a threshold into more dramatic activity cannot yet be determined with certainty. The monitoring networks provide unprecedented detail, yet volcanic systems remain fundamentally unpredictable. Preparation must happen now. Structures need reinforcing, essential services require relocation, monitoring networks demand maintenance and expansion, and residents deserve clear warnings based on the best available science. Some areas may never again be safe for permanent living. The heat invading homes is not a metaphor. It is the volcano's message, written in warped floors and mineral-coated walls, that the threat is no longer hidden. If 500,000 people cannot stop the heat from destroying their own walls, what happens when the pressure beneath finally breaks?